So like what I've said a while ago, we'll be discussing word problems today. So there would be a bit of translation that we will be talking about. So let's have a look at our warm-up for today. Have you seen some of these puzzles? Learning a new language in algebra, or probably be more fluent in algebra. I'll do one as a hint. If you've got there first, second, this is the third, and therefore this symbol means third time lucky. An inside job, yes, that's correct, Saran. Okay, inside job, an inside job. And then for the last one there, you might need to solve that. So that's an inequality that you'll have to solve. I know that we haven't done that, but it's cool. So you've got 3 multiplied to I plus 1 is less than 2I plus, that's a T, not a plus, plus 3 multiplied to U plus 1. Yeah. So what we need to do here is to expand or distribute these onto each of the terms inside the brackets. 3 times I is 3I. And then 3 times 1 is 3, less than 2I plus 3U plus 3. Right. Now we can cancel out all the 3's there. So when you have inequalities, they're the same as how you solve equations. So if you've got 1 on one side and the same on the other side, then you can just cancel them out. Okay. Then you've got 3I minus 2I, you get I. What does that look like? Maybe I'll need to like make them closer to each other. So that's a symbol. I love you. That's right. Okay. So if you want to impress someone, you might want to save that for later. Okay. Yay. So we're converting worded sentences into algebraic equations today. We've looked at heaps of solving equations, or equations that we solved with different strategies. We looked at guess and check, we've looked at cover-up method, and also our algebraic one, which well, all of them would be algebraic anyway, but the other one would be the inverse method. Yeah. So what we want to do now would be to solve some practical word problems, right? That would result into an equation, and therefore we'll be able to solve that equation. Now, some of the words that we learnt, right, that would involve what? Adding, subtracting, multiplication. There would be heaps of them, right? Just like when you say, let's have a look at these ones here. Write linear equations for each of the following statements using X to represent the unknown. Do not attempt to solve the equations. Well, you can if you want to. All right. So when you say when 6 is subtracted from a certain number, the result is 15. So it's literally translating that into an equation. So when you say 6 is subtracted from a certain number, so the unknown is X, the result is 15, right? So it's really writing that sentence into an equation, okay? So once you've got your equation, then you can solve that, okay? So the skill is translating it, and that's probably why this question asks us not to solve it anymore. But, well, what can they do? We can do what we want. We can solve that. We say we add 6 on both, right? And therefore we get X equals 21. And therefore you say the unknown is 21. Okay, let's have another example. It says here, let 3 more than 7 times a certain number is 0. So 3 more than 7 times a number. So you don't write 7 times X, but what we learned in algebra is that when it's multiplication, we just write one after the other, making sure that you write numbers first before the letters. So 7X plus 3 gives us 0. Oh, that's where the color is. Okay. All right, and then if we solve it, we say that 7x equals -3, and therefore x is -3/7, and leave it as a fraction. In a basketball game, Howe scored 5 more points than Steve. If they scored a total of 27 points between them, how many points did each of them score? So this one here, you've got two things involved, but you don't have to use two variables here, because you can represent the other one using the score of Steve using the score of Howe. Okay, so it says there Howe scored 5 more points than Steve. So if you represent Steve's score as S, so let's just say S, right? So Steve's score, sometimes it would be easier to use not just the letter X, but use the first letter of the names or whatever objects they would be using in the problem. Okay, so that later on you won't be confused whether you've represented X as Steve's or Howe's. Okay, so if S is Steve's score and it said that Howe scored 5 more than him, 5 more than Steve, then you could say that S plus 5 would be Howe's score. Okay. If they scored a total of 27 points between them, how many points did each of them score? So now you need to add both of them together. You can put S plus 5 into brackets just so you know that this is Howe's score, right? And that's equal to 27, right? And now we can say that's 2S plus 5 equals 27. And if we minus 5 on both sides, then we get 2S equals 22. And S must be 11. So now you know that it's Steve's score that you've gotten, right? And if you're asked how many points did each of them score, you can say that Howe, or you could say Steve scored 11, and Howe, what's 11 plus 5? Then that's 16. Howe scored 16 points. Okay, the expectation is you write the answer into a sentence form as well. Okay, right? So you write your representation, you write your solution. Okay, you write your equation, then your solution. So let's maybe, oh, I know to change that now. So R represent E, what's your equation? S, solve the equation, and then your statement answer. Okay, RESA. All right, I'll see you soon. Bye.